Okay, good evening. Welcome to
MinuteMath154.
MinuteMath154. This actually isn't really the Minute Math problem from today, but it's a problem number 13 from the 1998 AMC 8. Boy, 1998, that was a long time ago, right?
Yeah.
Phew. Ancient times, right? Okay, so here we go. I tried to draw this. It took me 3 times to get to draw it this good, so we're sticking with this even though it's not perfect. What is the ratio of the area of the small square to the big square? Okay? And you had a bit of a tough time with this, right?
Yeah.
Well, let's talk about what we need to know to solve this problem, and what might you think would be useful to know to find the ratio of the area of 2 squares.
Well, the areas of the squares.
Okay, so what do we need? Good. To find the ratio of the areas of the squares, we're going to find the areas of the squares.
And we need to find this.
We need to find that, x.
And this.
Let's call that y. Okay? Now, do you see any ratios in the picture that might be helpful in understanding? Do you see any ways anything get divided or got divided?
These this one and this one are equal.
Okay, they look like they're equal. We're not
Yeah.
sure. Okay, and do you see anything else that looks equal?
These 2 big ones.
Okay, good. How about line segments? Do you see any line segments that got divided?
This line segment right here.
What did that get divided into?
Into fourths.
Got divided into fourths. Ah, anything special about that line segment?
It's 4 equal pieces.
Aha, it's 4 equal pieces. Anything else special about that line segment?
This is y.
Well, because I want to know if there's anything special about the line segment.
So, this line is 4y.
Uh-huh. And then what's this?
This is y.
Right. Okay. So now we got to do some geometry. This is 4y, and this is x. You see any way that x and y are related, x and 4y are related to each other?
Well, it's the diagonal of the square.
That's the diagonal of the square, yep.
And they form a big right triangle.
Forms a big right triangle. Now we're cooking with butter.
1/2 base times height. We can find the area of this triangle, multiply it by 2, and you get the area of the square.
That's true, but just taking x times x gives you the area of the big square. Now we're trying to find this length y in terms of x. Okay, so how can we find the length of this diagonal? You don't know a lot of geometry because we've never studied it. What tells you the length of this side of a right triangle?
It's the Pythagorean theorem.
What does the Pythagorean theorem say? How long is this side here?
It's x.
Okay, so what's the Pythagorean theorem say?
A squared plus b squared is c squared.
Okay, so how does that come into play in your big triangle
So it's
here?
x squared plus x squared. It's this plus this.
Equals what?
Equals 4y squared.
What is 4y squared?
It's 16y squared.
Correct. Okay, now solve this. What does this side become?
It's 2x squared equals 16y squared.
Right?
We can just change this into x squared equals 8y squared.
Okay.
And we can just take the square roots of
Very good. You can just take the square root. So x equals
8y.
Sure.
Alright, the square root of 8y squared.
What is the square root?
It's just this part.
You sure?
Well, the square. This is the square root of 8 times y.
It's the square root of 8. You got to take the square root of both things. So let's write this just to be perfectly clear as the square root of 8 times y. That way we won't get confused.
Alright.
Okay, now can you simplify the square root of 8? Do you know how to simplify the square root of 8?
No.
Pretend like you do. What would you do to simplify the square root of 8?
Well, the square root of 8, it's a perfect cube. It's the square root of 2 squared times 2. So we could do, it's 2 times the square root of 2.
2 times the square root of 2 times y. So the square root of 8 simplifies a little. Okay, so that's pretty cool. Now, so x equals 2 times the square root of 2 times y, but what we really want to know is y Well, that's all right. Actually, oh, you know what? I have led you astray a little bit. Forget about simplifying the square root of 8. What's the area of our big square? Big area.
In terms of y, or just in terms of x?
In terms of x.
X squared.
X squared.
So.
What's the area of the little square?
It's y squared.
What does y squared equal?
Y squared.
In terms of x.
Y squared, in terms of x, well, it's x squared over 8.
X squared over 8. So the little area divided by the big area is x squared over 8 over x squared.
Which is x squared times x. Well, this just gets flipped up.
What gets flipped up?
This bottom area gets flipped upside down.
Okay, but what's on the bottom?
8 over x squared. No, it's just x squared.
X squared, so this is x squared over 8 times 1 over x squared.
And then the x squared cancel and you get 1 over 8.
1/8.
Which is the right choice.
There you go. Okay. That's a tricky one for not having studied algebra. Or geometry, I mean. Okay, cool problem. Good problem. Now we're going to do that 5 triangles problem.